We're on page 67, which is the last page for factoring on topic 13. And the problems we're going to do are 8Q, 8T, 8V, and then we're going to do 9E and 9F. So if we start with 8Q on page 67, we've got 25x cubed plus 65x squared minus 30x, and we look for the greatest common factor. We ask ourselves what's the highest integer that will go into 25, 65, and minus 30 and give us an integer solution. And 5 goes into 25 5 times, 5 goes into 65 13 times, and 5 goes into minus 35 times. So if I factor out 5x here from this term, 5x times 5x squared gives me the 25x cubed. 5x times the plus 13x gives me 65x squared, and 5x times minus 6 gives me the minus 30x. So I factor this out, and then by the distributive rule I can see that this is equivalent to that. Now, as far as this is concerned, I multiply the coefficient here 5 by minus 6, that gives me minus 30, and I ask myself, what are the factors of minus 30 that sum to plus 13? And the answers are 15 and minus 2. Of course, there are many factors of minus 30. I could say, for example, 6 and 5. But 6 and 5 cannot be summed to give you plus 13. Another set of factors are 10 and 3, or minus 10 and 3. There's no way that you can sum minus 10 and 3 to give you plus 13. So plus 15 and minus 2 multiply to give you minus 30, and plus 15 and minus 2 sum to give you plus 13. So now what I do is, instead of writing 13x here, I write plus 15 minus 2. Okay, so we now have 1, 2, 3, 4 terms, and I factor by grouping now. And out of the first 2 terms, I'm going to take 5x. 5x times x gives me the 5x squared. 5x times plus 3 here gives me the plus 15x. Out of these 2 terms, the common factor is 2. So I've got minus 2 times x gives me minus 2x. And minus 2 times plus 3 gives me minus 6. Now I look at this here. These 2 terms, 5x x plus times x plus 3 minus 2 times x plus 3, and I can factor out x plus 3 from here and from here. I put it here, and then I have 5x minus 2. Of course, the 5x was the greatest common factor, and that's you bring that all the way through to the end. So the 5x is the greatest common factor. Here, from here, I factored out x plus 3, and I'm left with 5x minus 2. If I go to the next problem, I have 8t x plus 1 squared minus x plus 1 minus 6. There's no greatest common factor here. There's no number or variable that I can take out. So to make this a little simpler to work with, you may be able to do this without doing this, so that's okay. But what I'm going to do is I'm going to let y equal x plus 1. In other words, instead of x plus 1, I'm going to substitute y. So this term would be y squared, this would be minus y, and this would be minus 6. So I get y squared minus y minus 6 if I replace the x plus 1 with a y. So now I say, what are the multiples of minus 6, the last term here, that sum 2 minus 1, which is the middle term here. So note that the coefficient of y is minus 1. The coefficient of y in this trinomial is minus 1. There's implied 1 right here. So that's where I come out with a minus 1. So I say to myself, what are the multiples of minus 6, which is this number here, that sum to minus 1? And the answer is minus 3 and plus 2. When I multiply minus 3 and plus 2, I get minus 6. And when I sum them, I get minus 1. So now, instead of writing y squared minus y minus 6, which is what I'm trying to factor right over here, I'm just repeating that, I write y minus 3 here because of that, and y plus 2 because of that. And now I substitute x plus 1 for y. I go and reverse the procedure. And instead of everywhere that y appears, I'm going to place it with x plus 1. So instead of writing y here, I'm going to write x plus 1. This minus 3 is that minus 3. And then for y here, I'm going to substitute x plus 1, and I've got the plus 2 here. So now I've got x plus 1 minus 3, which becomes x minus 2. And x plus 1 plus 2 becomes x plus 3. So what I did initially was replace the x plus 1 in this with y, and then I reversed the procedure. I replaced the y with the x plus 1. So, but you can see, for example, you might be able to do this without using that procedure. I just think it's simpler to do that, and it's a good way to learn when you have more complicated terms. Now, 8v, we have to factor this completely, and we've got x minus 1 cubed minus 8. There's no greatest common factor. Now I'm going to rewrite this as x minus 1 cubed. I'm not changing that, minus 8. I'm going to put 2 cubed instead of 8. That's the only thing. Restate the problem. So now it's a difference of cubes. So this term becomes my first term here, and then minus here, and this becomes this term here. So this is a difference of cubes formula. X minus 1 is the first term here, minus 2 is the first term here. So I square this one, and I get this. I multiply minus 2 times x minus 1, and change the sign. I get plus 2x minus 1, and I square minus 2, and I get plus 4. Now, x minus 1 minus 2 becomes x minus 3. So I've simplified what's in this bracket here. Minus 1 and minus 2 is minus 3. Now I rewrite this, x minus 1 squared, and I remove this bracket here. I get 2x minus 2 plus 4. Now I'm going to simplify this, and this becomes x squared minus 2x plus 1. This 2x is this plus 2x, this minus 2 is this minus 2, and this plus 4 is that plus 4. So all I've done in going from this line to this line is multiply x minus 1 times x minus 1. That gives me x squared minus 2x plus 1. Now, simplifying this, you can see the minus 2x here and the plus 2x cancel. So there's no term in x. So I just have the x squared here. And then plus 1 plus 4 is plus 5. Subtract 2, I get plus 3. And that's the final solution here. Now, I could have also done it, substituted, instead of x minus 1, I'm going to replace it with the letter a. So I'm going to let a equals x minus 1. So if I rewrite the problem as this becomes a cubed minus 2 cubed. So a is here and minus 2 is here. I square this term, I get a squared. I multiply minus 2 times a, I get minus 2a, reverse it, plus 2a. Change the sign, make it opposite. And minus 2 times minus 2 is plus 4. Now I go back and reverse the procedure. I let a replace a for x minus 1. I'm going to replace a again with x minus 1. And I've got it right over here. So I've got x minus 1 right here. Take this a, replace it with x minus 1. And the minus 2 here is that minus 2 here. Okay, this term is x minus 1 squared plus 2a is 2x minus 1. And the plus 4 and the plus 4 is that. So now when I simplified this, this is identical to what we did before, no different. And I get x, if I simplify that, I'm going to get x minus 3. This bracket here becomes x minus 3. And this simplified, which we did up here, simplifies to x squared plus 3. Now, to determine whether a trinomial is factorable over integers, meaning is there an integer solution in the factor of this, I go back to the rule which says that if we have a trinomial, ax squared plus bx plus c can be factored over integers only if b squared minus 4ac equals 0, 1, 4, 9, 16. Now, if b squared minus 4a is 0, it is a perfect square trinomial. In other words, whatever is in the first term is identical to whatever is in the second term. But if the number is a perfect square number, like 1 is 1 squared, 4 is 2 squared, 9 is 3 squared, 16 is 4 squared, 25 is 5 squared, 49 is, what did I say? Sorry, let me go back. 25 is 5 squared, 36 is 6 squared, 49 is 7 squared, etc., etc. So you could add numbers here. It goes dot, 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 meaning there's a lot of numbers. So if we go back to this one here, a is the coefficient of x, which is 2, x squared. A is the coefficient of x squared, which is 2. B is the coefficient of x, which is 5. And c is this number here. I compute the b squared minus 4ac, and b is 5, so it's 5 squared minus 4. A is 2, and c is minus 5. 5 squared is 25. Minus 4 times 2 is minus 8. Minus 8 times minus 5 is plus 40. So I get 65. Is 65 a perfect square? No. 64 is a perfect square, and which is 8 squared, and 9 squared is 81, but 65 is not. So we can't factor this using only integers. We go to the next problem, same kind of a problem with different numbers. We have ax squared minus bx plus c. So a is 9, b is minus 3 here, c is minus 2. Those are the coefficients. I calculate b squared minus 4ac. B squared is minus 3 squared, which gives me 9, minus 4ac, and 4 times 9 is 36. 36 times 2 is 72. And of course, because there's a minus here and a minus there, is plus. 9 times plus 72 is 81. 81 is 9 squared. So the trinomial is factorable using integers. And actually, if you look at this right here, you can see that if you factor this, 3x times 3x gives me the 9x squared, plus 1 times minus 2 gives me minus 2, and now I have plus 3x as my inner and minus 6x as my outer, and I get minus 3x. So here we can factor this using this is an integer, this is an integer, this is an integer, and that's an integer. And that's what b squared minus 4ac tells me. So this completes page 67.